right, so today we're going to talk about critical points and increasing and decreasing. I had said wanted to use this blank for the date. So today, or this lesson is supposed to be done on 8/27/20, but we may be evacuating for a hurricane. So if this lesson actually doesn't go on the 27th, put whatever date it is that this lesson actually goes with. All right, so first of all, critical points. So critical points are just like they sound, critical. It's where the point, where important stuff happens on the graph, right? It's where the points on the graph changes its direction or shape. Okay. So critical points, and then we have within that category of critical points something called extrema. Extrema are points where the graph changes direction. The function has a minimum or maximum value, relative or absolute, at these points, okay? The value refers to the y value. Anytime you're talking about the value of a function, that is your output or your y, your dependent variable, okay? So, and then we also have what's called a point of inflection. Even if you've never used those terms before or heard them, you've definitely seen them. It's where the graph changes its shape, but not its direction. Okay, so over here, we've got a maximum, we've got a minimum, and then it says relative or absolute. We'll talk about the different ones here in just a second. But a maximum, a minimum, and then here is your point of inflection. One of the graphs you have definitely seen with points of inflection is a cubic. Right, looks like this. That's your point of inflection. So it changes its shape, but not its direction. We're still heading in the same direction. So let's talk about the relative and absolute extrema. So if you have a point on the graph, a point with the greatest value compared to the points around it, okay, so not the greatest value overall, but compared to the points around it, this is called a relative maximum. All right, so I've got a relative maximum because it's not the largest value overall, but with the points around it right here. We just kind of zoom in to right there. Then when we have the point with the greatest value over the entire domain of the function, that is going to be your absolute maximum. Right, and so that would be this one. This is the highest y value that exists in the entire function. Right, and then when we have a point with the least value compared to the points around it, that's going to be your relative minimum. All right, so here's my relative minimum, or a relative minimum, because it's not the lowest point overall, or the one with the least value, but it is around there. Then we have the point with the least value over the entire domain. That's going to be your absolute. We will abbreviate these when we answer the questions, but I didn't want it abbreviated right now. So absolute, least value overall in the function. Okay, and relative max and mins are also called local max and mins. We'll call them relative, but you'll see that as well. All right, so here it says to give the coordinates and classify the critical points. So critical points, not just max and mins, right? The critical points of the functions. So here, this looks like the only one we've got, right? And that would be a minimum, but it would be an absolute minimum. So this is an absolute minimum. You can abbreviate, it's fine. I don't like abbreviating on things like this because I want you to know what the abbreviations mean. And then it says give the coordinates, so I need an ordered pair, and this would be at 4, -5. Okay. This one has 3 critical points. So see if you can figure out what they are and write them down. And I made this is light and it's bigger. You can write over this graph, I would hope, I think. Some of these are darker, but I think I can write over that one because there's not a lot of space. All right, so I have critical points here, here, and here. So this would be an absolute maximum, and it would be at -3, 1, 2, 3, 4, 5, -3, 5. This here is a minimum, but it's not an absolute minimum because this is going to keep on going, and so does this. So it's a relative minimum. So I have a relative minimum at, so 1, 1, 2, 3, 4, 5, 1, -5. And then here, this is a relative maximum at 2, -3. All right, number 3. So I'm still labeling all of my critical points. So I have this and this. That looks like it. So neither one of these are going to be an absolute because this function continues here and here. So that means I'm going to have a relative minimum at -3, 1, 2, 3, 4, 5, -3, 5. If I count, oh, -3, -5, sorry. If I count wrong, I'm sorry, but there's a huge glare on my board. 1, 2, 3, 1, 2, 3, okay. I don't want to take up too much of your time with me counting, but it's hard for me to see up here. All right, and then I have this point here, which is going to be a relative max. Ooh. So I get -1, 1, 2, 3, 4, 5, -1, 5. All right, so on number 4, I have 3 critical points. So pause, see if you can figure out what they are, and label them. This one, this one, this one. So again, these max and mins, they're not absolute. So this is going to be a relative max at -2, 1, 2, 3, 4, 5, 6, -2, 6. Then I have a 2, 0, I have a relative min, and that is at 2, 0. And then I have this point. Remember, we changed the shape, but not the direction. It's like what you have in a cubic function. This is called a point of inflection. Point of inflection. And that is at 0, 3. So let's talk about increasing and decreasing behavior. And more importantly, because I think you can figure out when it increases and decreases, but how you write it. The notation is important. Okay? So, moving from left to right, a function may increase, decrease, or remain constant on certain intervals. For example, the function to the right. The increasing interval, it's increasing from -infinity all the way to where it gets here. Okay? And the intervals that you write has nothing to do with the y values. It has to do with the x values. So I'm going from -infinity to -1 is when it's increasing. -infinity to -1. Right? At -1, it's not increasing or decreasing. Constant, the constant interval, here's where it stays constant. The y value stays constant, but I write the x interval. I go from -1 to 1, 2, 3, 4. -1 to 4. And then decreasing, go from 4 to infinity. So what you may need to remind yourself, because the mistakes that I see on this, I mean, I think you can point on the graph and understand the increasing and decreasing. It's what you are writing down. So here's the question you have to ask yourself, or really the question that you're answering is, what happens to y as x increases? Okay, so we're always going from left to right when we're talking about increasing and decreasing, all right? And so you're looking at what happens to y, like y decreases as x increases. So this is decreasing. And then what you write down are intervals of the domain. Okay, so you are talking about we are representing what is happening to y by writing down intervals of x. Okay, so keep that in your little brain here. Okay, so we are decreasing, so I'm starting over here. So when x is at negative infinity, right? So from negative infinity to right here, which is -2, I'm decreasing. Okay, so negative infinity to -2. And then let's see, am I decreasing anywhere else? So then I start to increase, then I decrease again, starting at 1. And so my x value is 1. I decrease till I get here, and my x value is 1, 2, 3, 3. So I have a union of these two, right? And then I'm going to go from 1 to 3. So then increasing. I'm increasing from -2 to 1. So here's my increasing. I don't care what the y values actually are. It's -2 to 1. And then I'm increasing again from 3 to infinity. So a union, 3 to infinity. Okay? Why don't you pause and see if you can do these next two. All right, so on number 6, we have asymptotes here. There's an asymptote here and an asymptote here. Okay? And when I'm talking about increasing and decreasing, remember, it's what is happening to y as x increases. So I'm going from left to right on my x-axis. This function decreases, 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 decreases. Then I have to jump to the other side of the asymptote, and it decreases, decreases, decreases. So it's decreasing the entire time. However, it's not decreasing over the entire domain, because here at 2, 3, 4, 5, at -5, I have an asymptote, and it's not increasing or decreasing. So it's decreasing from negative infinity to -5, and then from -5 to infinity. See, and I'm not including that -5. That's why I have to split it up. And then it's increasing none, because it's decreasing the whole time. On number 7, we also have an asymptote here, but we do not have one here. Okay, so it's increasing from negative infinity, and it keeps increasing all the way to infinity, so negative infinity to infinity, and none right here. So now we're going to talk about positive and negative intervals. So when the function is positive or negative, that means, again, we are looking at the y values of this. So I'm talking about y, I'm writing about x. Okay? So when the function is negative, that's everything below the x-axis. Everything down here is negative, everything up here is positive. And then this right here is 0, right? So my function here, it's positive from here to here. All of this is positive. So that's from 1, 2, 3, 4. -4 to -1. Okay. And I am not including either one of those because they are 0, right? And then that's it. That's the only place it's positive. Then it's negative. I'm below the x-axis here, and all of that, right? So I'm negative from negative infinity to -4, and then from -1 to infinity. All right? So why don't you pause and try and do 9, and then we'll talk about these. Okay, so positive, my function is positive here and here. So I'm positive from negative infinity to -1, and then from 1, 2, 3, 4, 5, 6, 7 to infinity. I'm negative all right here, so that's going to be -1 to 7. Then I'm positive here, right there, and then right there. Okay. So I'm positive from, looks like negative 1.5 to 0. I think I put all whole number stuff on your assignment. If not, don't get, it's either on a whole number or 0.5. I know that at least because I tried to change some of these where they made more sense. And then we go from 1.5 to infinity. It's negative here and here. So I'm going from negative infinity to negative 1.5. And then from 0 to 1.5. Okay, there's your increasing, decreasing, positive, negative, and extrema.